0. So, where was this function not defined at? 2. Okay, so in order for it to be continuous, that means it always has to be defined. So where would this be discontinuous at? It would be discontinuous at 2. Okay? Because 2 is, f of 2 is not defined. Does that make sense? Okay. Good on that one? Okay, what about the second one? Is it defined at every number? Okay, yeah, because even though this one isn't at 0, this one's defined at 0. So the first step is totally all taken care of. So now you gotta figure out, does the limit exist? Well, the limit, I just already talked about, of 1 over x squared, okay, as it approaches 0, that doesn't exist. Okay, so where is this, so this limit doesn't exist. Therefore, at the 0, even though it's defined at 0, at 0 is where it is discontinuous. Okay, now you would know this when you graph it. Because when you graph it at 0, you have one that has an open circle and one that has a closed circle. Okay, it can't be, I think they call it jumping in your book. Can't be a jumping domain. Has to be a continuous domain.
And why do we know that that limit doesn't exist?
Because when this cannot be factorable, okay? And as it approaches from either side, this would not work. So, well, if you put in 0, it doesn't work, because you can't divide by 0.
What if the second equation they give you fills in the whole?
Then they would have to be the exact, don't know, Ruthie, how you think about that. Okay? It'll be fine. I think it would be fine as long as the limit approaches the same number for both equations. If the limits do not approach the same number, I'm gonna say it's not gonna work. Okay? Well, let me think about that some more. Okay, so what do you think on C? Or would this be discontinuous at? 2, good. Alright. Do you remember what D is? What kind of function that is?
Is it a step function?
Step function. You know what they look like?
Or like the 2 circles?
Yeah. Steps. They do.
Oh, okay.
They look like this.
Peyton Starks, if you're in the building, would you come to the office, please?
Okay, so do you know where these would be discontinuous at?
Everywhere.
At every integer. Okay, so it's also called the greatest integer function because your answer is only integers. So at every integer it's discontinuous because it jumps up between points.
So if it has little brackets, that means it's automatically step function.
Yes, if it has the 2 brackets, yep. Okay, how do we feel about definitions of continuous? Okay, are you ready to prove something?
I think we should put a pin in it.
What? We should be done? I got a good 9 minutes left.
Like on
They're not really.
Paragraph.
No, when we were in geometry, Mr. Weiger, we had to write those stupid precise.
Yeah, I don't know what you're
I
saying.
got pretty
but
good
it's-
sick with a pen and ink stuff. Here's the movie Bolt. Yeah, when they say we're gonna put a pin in it.
I don't remember that part.
I don't know. Bolt's that movie with the dog, right?
Bullet, right? It's like,
Bolt.
it's Bolt.
B-O-L-T.
She was so.
Bullet, right?
Yeah.
Not Bolt.
Wasn't Miley Cyrus the voice of the girl in that movie? I like that.
Was she?
Yeah.
You don't know the movie very well. You remember the one little part that was like, let's put a pin in there.
I do not remember.
Because I laughed at it.
Everyone just sees the picture.
I give it a lot.
This will be the last thing we do, we'll do this example and then we'll stop, okay? Okay, so if you wanna show something that's continuous, you have to show that the limit that x approaches a of f of x equals f of a. Okay? Now, this says that this is on the interval from -1 to 1. So we're going to, if a is between -1 and 1, we're just going to let that assume that that's the case. You can put the equal to signs if you want. Okay, we're gonna find the limit as x approaches a of f of x. So we're gonna show that the left-hand side, and then we'll find the right-hand side later, we're gonna show that they're equal. Okay, so limit of x approaches a of f of x. Well, if this is my f of x, that means I'm gonna find the limit as x approaches a of 1 minus the square root of 1 minus x squared. Hey, remember the rules? If you have like two things going on, you can split it up. So then the limit as x approaches a of 1 minus limit as x approaches a of that